Hello and welcome to The People Behind Your Water. I'm Marty Grimes of the Santa Clara Valley Water District. In this episode, we're going to be taking a trip to Almaden Reservoir, which is one of the first 6 reservoirs built in this county. And because that reservoir is so dry this year, we actually are having to pump water over it just to keep the creek underneath that reservoir wet for fish. And while we're there, we're going to talk to Mark Merritt, one of our longtime engineers, who is the guy I go to whenever I want to know what's going on with the water supply picture, what's going on in the reservoirs, and how much water did we capture in that last rainstorm. So it's pretty interesting stuff, so stick around. So we're here at the top of Almaden Reservoir, and I'm here with Mark Merritt. And Mark, what's your title at the Water District?
I'm an associate engineer in the Water Supply Operations Planning and Analysis Unit.
That's a lot of words in a unit. What does your unit do?
Well, we plan for essentially our reservoir and recharge operations, also coordinate with imported water, essentially local source of supply, and groundwater recharge.
Okay, so basically you're watching this reservoir real closely and all the other reservoirs and making decisions about how to operate it, right?
That's correct. These reservoirs essentially were built for water conservation originally. We use this water essentially to release during the summertime to put into our groundwater recharge facilities, this one in particular. And so that's a lot of essentially what our planning activities are. During the winter time, hopefully when the rains come, that's when our diversion period is, and that's when this reservoir will hopefully fill.
And what do you mean by a diversion period?
That's when we can actually, by our water rights, we can actually put water into this reservoir.
Okay. We're able to divert water from the watershed that's coming down the creek. So the creek that feeds there's a couple of them, but the main creek is Alamitos Creek.
That's correct, Alamitos Creek.
And Alamitos Creek runs downstream of here all the way till, tell me where that creek goes, where it leads.
It leads down to the confluence of Calero Creek, where we have another reservoir that's releasing water, and then it continues on to the confluence of the Guadalupe River and Alamitos Creek, and then ultimately out to the bay. But before it gets there, we have in-stream recharge as well as off-stream recharge, and that's part of what this reservoir supplies.
So
recharge.
How does that work, the in-stream recharge? What does that mean?
The in-stream recharge is just natural recharge that occurs. I mean, we have essentially managed releases from the reservoir, but that water, as it's moving downstream, is going into essentially what we call our forebay or our recharge zone. And then as you get a little further down into the recharge zone, we have off-stream facilities. So you get a combination of in-stream recharge in the creek, which is pretty productive. The creeks themselves, they clean themselves every year when we get a big flow.
Meaning the sediments are flushed downstream?
Right, when you get some flushing flows and that sort of thing. Whereas our off-stream facilities, we actually have to go in and clean them periodically.
Because they're not flowing.
Right, and the water is essentially not moving at all.
So this reservoir It was built in the 30s, is that right?
Built in 1935.
So one of the first reservoirs at the water district.
One of our first 6 reservoirs.
Built expressly for that groundwater recharge that you were talking about.
Yeah, groundwater for water supply conservation. The Santa Clara Valley essentially is the poster child for land subsidence from about, the early 1900s till about 1970. We had in San Jose and parts of Sunnyvale, we had about anywhere from 12 to 14 feet of land subsidence. And that was recognized with the founding of the district in 1929. And so in 1935, we had a number of public works projects that built these storage facilities to try and capture that rainfall and put it into the ground and try and get groundwater levels to recover. And
which it did
around 1970. Land subsidence has been held to pretty much minimal amounts.
So the system has been working. We're able to capture water in the winter, release it down these creeks in the dry months for recharge during in the stream, and then our recharge ponds off stream add to that.
That's correct. So that's helped replenish wells, as well as our treatment plants on our imported water. That took a lot of pressure off the groundwater basin. So, it's a combination of those two things.
Yeah. So that's a good point, that we added the imported water and added the treatment plants so that we wouldn't be overdrafting our
groundwater basin. So it gives us a lot of operational flexibility. So yeah, it's a very flexible system. We have a lot of options as we're operating, and that's one of the things our unit tries to do is coordinate between imported water and our local supplies. We've only got one set of pipelines, so is it going to be Anderson water, or is it going to be San Luis water coming in?
It's going to the treatment plants.
Right, or to our recharge program too.
Okay, because we do release imported water and Anderson water both for recharge.
That's correct. Yep.
So this reservoir is relatively small.
It is. This reservoir is one of our smaller reservoirs. It's about 1,500 acre feet. It's a very productive watershed. It's about 12 square miles here. And this, I was looking at the data, it's spilled about 37 times since it was built. So this watershed does produce, a lot of runoff. The problem with it is at its capacity, it's essentially enough storage for a single year, and that's part of what you're seeing here is 2 dry years in a row, and very low storage in the reservoir. So
2 dry years in a row, but I remember that last year in 2012 at the end of the year we had a lot of really big storms around Christmas, and this reservoir didn't look like this.
This reservoir actually spilled in December. We had about 300 acre feet of water go over the spillway. We also made about 1,500 acre feet, or about the equivalent of one whole Almaden Reservoir. We released it through the outlet because of our Division of Safety Dams restriction, our seismic restriction here.
Okay. So this is one of the dams where we have some restrictions because it's because of the spillway isn't sized large enough?
Yeah, it's not sized large enough for the probable maximum flood. This dam is actually seismically, it's in pretty good shape as our dams go. And then we also need to possibly conduct some work on the intake structure and the outlet works.
Oh, okay. And so right now this dam is restricted to about 90% or something of capacity?
It's 1 foot below the spillway. So it's about 1,472 acre feet.
That's the restriction?
Yeah.
Oh, so it's really just a foot difference.
Below. So it's not that much of a restriction. That's essentially an incentive from Division of Safety of Dams for us to go ahead and complete the work on the facility.
Okay.
And then we'll be able to fill it.
All right. So that was the interesting thing, that this was spilling just a year ago, a little less than a year ago, and now it's practically empty. How much water is in the reservoir right now?
It's about 66 acre-feet left right now, so that's less than 4%, I think, of the total capacity. And what happened this year is we got all of the rain, essentially an entire year's worth of, well, we got about a 80 to 90% exceedance probability, which...
Oh, you're doing exceedance probabilities on me.
So, 8 times out of 10, you would expect more water or more runoff than what we got this year. And the previous year was a 90% exceedance, so 9 times out of 10, you'd expect more water than we got in that 1 year. So
we've beat the odds in a negative way for the last 2 years.
Yeah, in a very negative way. And then it also had to do, I think, with the timing. It all came at once. Essentially, in December, we hit our restricted levels, so we had to let that water go out of the reservoir. When the rain comes all at once, you're not spreading it out over, the normal rainy season. You're not keeping the creek wet below. You're not keeping your, sustained inflows to the reservoir. So we've had a very long stretch here where we've essentially just been drawing from storage to try and keep the creek wet. And
how much water's flowing in? We can kind of see upstream here. That doesn't look like much. Is there any water coming into the reservoir right now?
There is a little bit. There's about 8/10 of a CFS.
8/10 of 1 cubic foot per second. And this reservoir is so low right now that we're not even able to release water from the outlet at the bottom of the reservoir like we normally do.
That's correct, and so that's why we're essentially pumping over the top right now.
This is not common that we have to put a pump in the reservoir and pump over the spillway?
No, it's not very common, and it's something that we'd like to avoid, but we couldn't do it this year.
So we're pumping, you said 1.2 cubic feet per second, which means that we're still releasing more water than is coming in, hoping that it's going to rain.
That's correct. Yeah, we're hoping that essentially this operation has been to try and reduce the releases from the reservoir, to try and maintain as much creek downstream as we possibly can wet for the fish that live there, and then try and maintain some storage in the reservoir and try and get us into that rainy season, which will be soon.
Yeah, so we're right now, today is November 19th, is that right?
I think so.
November 19th. So how many more days from today do we expect that we can continue this pump over operation without it being so low that we can't pump anymore?
I think we figured that we could go to about the first week in December, first couple of weeks in December. And then at that point, if we don't get any runoff, we'll have to make some more decisions on what we're going to do with that remaining storage.
So what do you think will happen? What happens if it doesn't rain and we're not able to pump anymore?
I think what'll probably happen this year, if you bring it out to its ultimate end, if we don't get any rain, we'll bring this down to about 50 acre-feet of storage, and then we'll try and match our inflows. So whatever's coming in, we'll continue to pump over and try and maintain that water level. But that's also a function of how much rainfall and runoff we get. Ideally, even in a 90% exceedance year here, this reservoir will fill.
And how long would it take? What kind of storms would we need to get to see this reservoir fill? And then how long would it take for it to really bounce back?
For the way this watershed is looking right now, you'd probably take a couple inches up there to...
A couple inches, like here, or up in the watershed?
In the watershed to start to get some inflow. And then to start sustaining inflow, probably at least another 5 inches.
Wow.
Yeah.
When that happens, that we get storms with 5 inches of rainfall in these mountains. That's a good storm, right?
The average rainfall for, say, Mount Eminem is over 40 inches of rain a year. So, compared to 14 inches in San Jose. So
it's just a matter of timing. That we're just hoping that it'll come soon before we don't have enough water left to pump over the spillway.
That's correct. Yeah, just hanging on until the rains come.
Are there other reservoirs that we're concerned about this year?
I want to say no, but yeah, Stevens Creek is actually not too worried about the storage so much. We've reduced those flows. So there has been the creek has been dried back a little bit, so there have been some issues there.
Guadalupe?
Guadalupe is low, but it still has some fairly decent reserves. Guadalupe watershed is about half the size of Almaden, and it's not a very productive watershed. So we have a tendency to carry over more water in that watershed than we do here.
So when you said this was a productive watershed, you're saying that a lot of rain, enough rain falls up above this reservoir that a lot of times we can't capture all that rain.
That's correct, and
that's why it has spilled more than 30 some times.
That's right. It'll spill pretty often, and that's also why we have a canal that's connected between here and Calero Reservoir.
Yeah, that's kind of interesting too. How much water can we get into? We can move water from this reservoir to Calero Reservoir because that's a bigger reservoir.
Right. When they designed this system, as I mentioned, this reservoir watershed area is 12 square miles. Calero is only about 6 square miles, but Calero holds 10,000 acre feet without restrictions, and this only holds 1,500 acre feet.
So much larger reservoir over there, and the square mileage of this watershed is bigger than the Calero one.
Right.
Oh, too bad we couldn't have built a bigger reservoir here.
What they did is they said, okay, we're going to build Almaden, and we're going to go ahead and transfer water, and we can transfer up to 6,000 acre feet. According to
it was by design to have that canal water transferring to that other reservoir.
That's correct. Yeah. So this system actually works out pretty well for local supply, provided we don't have a restriction at Calero, which we do. Yeah. So yeah, this is a very, very productive local water supply facility.
So we're looking at the meter here for this pumping operation, and you had guessed that it, just by eyeballing it, because you've been at the water district for so long, you thought it was, what, you guessed?
About 600 gallons per minute.
600 gallons per minute. I said 3 gallons per minute because I don't know what I'm doing, and it's 550, so you almost had it.
Almost there.
So when was the last time it was this low?
Last it was 1997. It was actually lower than this.
Did we have a pump over operation that time?
I don't believe so. At that time, we were just making outlet releases, and then the rains came.
Ah.
Yeah, and it was about this same time. I think it was about November 15th, so we're a little later than that.
But unfortunately for us, the forecast looks...
We've got this one system that's going to be coming through, and then our forecasters are saying dry till the end of the month.
I'm glad we got that on tape, because as soon as we post this, we're going to be wrong, right? And it's going to rain.
I'll take it.
We'll take it.
I want every forecast to verify, but in this case, bring it.
Bring it on.
Yeah.
So tell me more about this dam. I see some telemetry equipment, or what is it measuring?
It's seismic monitoring. So we have there's inclinometers and accelerometers in the dam. So they're just measuring movement within the dam. It's from our dam safety program.
Cool. And this dam, like all of our dams, is a earthen dam, most rocks and clay and that kind of thing, right?
Yeah, it's an earth-rolled dam. In addition to the seismic monitoring, there's also piezometers or wells that are measuring the water pressure inside the dam as well.
Which is an interesting concept, that there's any water pressure inside the dam. Is that just the natural thing? There's always water pressure in the middle of the dam, and the water's not stopped at the upstream side?
Yeah, I mean, it's a function of how much water is behind the dam, certainly. As you'll see as we get down here, there are actually some seepage weirs. So there's water, coming through the dam. It's a lot less than if it were full. So yeah, that's a normal occurrence.
Yeah, that's a little trippy too, to realize that it's a natural part of the dam like this, that water is actually seeping through. But we're not concerned about that. it's just what happens.
We'd like it to be zero, but what we're really concerned about are changes in the flow and changes in the color of the flow. If it's muddy, that would be concern.
This is a seepage weir that is actually measuring the water that's actually flowing actually through the dam.
That's correct.
Probably can't hear you without a mic. So, and if there was an earthquake, we have teams that come out, and what would they be looking for?
Yeah, but these are actually monitored on a regular basis by our field operations. So you have a long history of what the flows are and what they look like. But you're right. After an earthquake, you'd come out and you'd make sure none of the water was muddy. You would also inspect the outlet, make sure that you didn't see any mud coming out of or dirty water, which would indicate that there's a problem with the outlet pipe.
All right. So we're at the bottom of the dam here. So we're here at the bottom of the dam, and this is Alamitos Creek, and this creek is an important creek for fish.
Yeah, it is. It's a creek for native species, steelhead, California roach. So yeah, it's an important creek.
And that's why we're going to these great lengths to pump water over the spillway up there to keep this creek as wet as we can, as long as we can, so the fish, hopefully we can keep as many fish surviving in this dry year. That's correct.
So we're trying to essentially use limited amount of storage left and try and let out a reduced amount of water to maintain as much creek as we possibly can, hopefully getting us into the rainy season. And we also, the fish benefit from that, except with the exception of where it's dried back. But it also benefits our water supply. So both of those objectives.
Because we're still doing the in-stream recharge. The water's still going into the groundwater basin.
That's correct. That's correct. So, it's good for the fish, or the water that we release for water supply also supports their habitat.
Okay. So not long ago, we actually reduced the flow into the creek in order to extend the amount of time that we have water available. And how did that change things downstream of here?
Well, from our field estimates, from our biologists and our field operations, it looks like the creek has dried back from the confluence of Calero about 1,500 feet.
Mm-hmm. So 1,500 feet of pretty dry creek.
That's correct. There's some pools there, and it's been sort of fluctuating in that zone. And the objective there is to, we lost a little bit of creek, trying to maintain, the majority of the creek with what limited storage we have left, and then hopefully get some rainfall.
And what would have happened, say, 100 years ago in this watershed if we had the kind of weather that we've had and we didn't have a dam here? What would this creek look like without the reservoir?
It's likely that and about this point here, maybe even a little further on upstream, it may be dry. Almaden typically does have inflows all year round, but whether or not it would make it this far down. So without the dam, we wouldn't have as much wet creek going down to the confluence.
And we should point out here that what we're looking at is where the water comes out typically from the outfall or the outlet of the reservoir, but there's nothing coming out there right now.
That's correct. The downstream valve is closed right now, and what we saw at the top of the dam is essentially what's feeding the creek right now.
Right. Which is so what's feeding over that spillway that we saw is actually entering the creek further down from where we are.
That's correct.
Anything else about the creek situation that we didn't cover yet? Anything that we missed, any guys? Well, I hope you found that as interesting as I did. Operating our reservoirs is pretty tricky stuff and a lot more complicated than I thought. So now let's just hope we get some rain. And if you want to check out how much rain we have received or check our reservoir levels, you can always go to our website at valleywater.org. And we'll also be posting information about our water supply outlook on Facebook and Twitter this winter, so check us out there. So thank you for joining us, and we'll see you next month on The People Behind Your Water.